So in this short video, we're going to kind of specifically focus on differentiating with negative and fractional indices. It's not really anything new, but this is something that comes up a lot, if not the most, when it comes to factorization and or rather differentiation. And so this, I just wanted to take this or make this short video about specifically negative and fractional indices. So we've been speaking about the chain rule and differentiating with the chain rule, but so far we've only really looked at one kind of question, which is when we have questions like let's say minus 5 x to the power of minus 3, right? So we know how to differentiate this without using the chain rule, right? We just bring the minus 3 to the front, so y prime is going to equal minus 5 times minus 3, and then this minus 3 goes down by 1, so to the power of minus 4, and so we get 15x to the power of minus 4, right? So we know how to do these kind of questions. We're really familiar with that. We just drop the power and then we decrease it by 1. But I do want to show you some different ways that I guess examiners can trick you into thinking, oh, I've never seen this before, but really you have seen it many times, right? For example, if I asked you to differentiate something like 1 minus 3 minus 2x squared, some students might, freeze up and be like, oh, I don't know what to do when we have the terms all in the denominator. But really, it's nothing new, nothing different, right? If I just rewrote this as y equals to, in brackets, 3 minus 2x squared, all to the power of minus 1, because these two, they're the same thing, right? Now all of a sudden this becomes something we're really familiar with. We can use the chain rule. So if I did that, y prime equals, we differentiate what's inside the brackets. So 3 is, it becomes 0. Minus 2x squared, that's minus 2 times, we bring the 2 at the front, so times 2, and then we drop it by 1, so 2x. So that's the derivative of what's inside the bracket, and we times that by the derivative of this whole entire thing. Remember, we kind of imagine this as u to the power of minus 1, right? So I'm going to bring that minus 1 to the front, so times minus 1, and then we leave the bracket as it is, and then this entire power decreases by 1, so to the power of minus 2, right? And so if we simplify this, it becomes minus 4x. Well, actually there's two minuses, so positive 4x, and then 3 minus 2x squared, or same thing as saying to the power of 2, or to the power of minus 2, or 4x over 3 minus 2x squared, right? So by recognizing that this is actually something we're really familiar with, is actually going to really help us. And so if once we're familiar with this, and once we expose ourselves to these kind of questions multiple times, we can really easily manipulate this into a form that we're really familiar with, and then just use the chain rule or some other technique to get the answer. So now I'd like you to have a go at these 4 questions, which will kind of test how comfortable you are with differentiating with these negative indices. So let's have a look at part A here. We have y equals to negative 1 over x squared. And I immediately recognize that this is, in this form itself, I can't really differentiate it. So I'm going to write it as negative x to the power of minus 2, right? Bring that x squared to the numerator. So all I have to do then is differentiate it. So we have a minus 1 just at the front here. And then I'm going to differentiate it. So bring the minus 2 down. So minus 2x, and then that index decreases by 1, so power of minus 3. And then that just becomes 2x to the power of minus 3, or 2 over x cubed. So that is my answer for part A. Part B, very similar idea, so 3 over 2 plus x. We can rewrite that as 3 times 2 plus x times 2 plus x to the power of minus 1. And then I'd use the quotient rule, right? And this 3, don't let that trick you or distract you. We're really not going to worry about that, right? So it's just like if I asked you to differentiate 3x to the power of minus 1. You would bring that minus 1 to the front, and then this power would decrease by 2, right? So negative 3x to the minus 2. That's pretty much what we're going to do, except we have the added step of differentiating what's in the brackets and multiplying that as well, because we're using the quotient rule, right? So let's do that first. We have a 3. We're going to differentiate what's inside that bracket, which is just going to be 1, because 2 is nothing. Differentiating x will give you 1. And then we're going to bring this minus 1 to the front. So minus 1, or just minus. Leave the brackets the same, 2 plus x. And then decrease the power by 1, so minus 2. And so now we get minus 3, 2 plus x to the power of minus 2. Or just minus 3 over 2 plus x squared. And that would be our answer there. Part C, it's just trying to get more and more complicated, but again, don't let those extra parts confuse you. Nothing is really changing here. So minus 2 on 3, 2 minus 5x squared. I'll rewrite this as minus 2 on 3, 2 minus 5x to the power of minus 2. And so I'll differentiate that now. The minus 2 on 3 just stays there. I differentiate what's inside the brackets, which is just minus 5. And then I bring the minus 2 to the front, minus 2. Leave what's inside the brackets, 2 minus 5x, and then decrease the power by 1. So you can see how this is really a very systematic, very stepwise method of finding the derivative, right? So now I'm going to simplify these 3 terms. I get, that's 10, so minus 20 over 3, and then 2 minus 5x to the power of minus 3, or I can write that as minus 20 over 3, 2 minus 5x to the power of 3. And that would be my answer to part C. So now finally, part D, we have 1 to the power, 1 over x minus 2 minus 3, right? So I can think of kind of 2 ways to do this. Both are pretty much the same thing, but the first one is to just simplify this right off the bat, right? So minus 2 times minus 3, that would get us 1 over x to the power of 6. We can do that. Remember our index laws. If something is, big brackets to the power of something, then these 2 terms would multiply each other. And from there, we just have to, we can write that as x to the power of minus 6. And so y prime would be minus 6x to the power of minus 7, right? Or just minus 6 over x to the power of 7. So I also wanted to quickly talk about fractional indices and differentiating these fractional indices. So just as I gave the examples with negative indices, questions might present you with questions like something like 2 to the power of root x, right? Well, actually, let's start even simpler. 2 to the power of 2 times root x, right? And now you might look at this and be like, oh, I don't know what to do. How am I meant to differentiate when there is a square root there, right? This is nothing I've ever seen before. Well, actually, it is. You have seen this before, right? I'm just going to rewrite x as to the power of a half, right? Because that's the same thing as the square root of x, right? And now again, this becomes something we are so familiar with. We've seen it a million times. Well, not a million times, but we've seen it a lot of times. And so what I'm going to do to find the derivative is just bring the half down. So it becomes 2 times a half, and then x a half minus 1, right? The same old trick we've been using. These will cancel each other, and so we get x to the power of minus a half, and we can just rewrite that as 1 over root x, okay? And so we could go a step further, and I gave the example of putting the root at the bottom. This just adds also negative indices as well. So we can write that as 2 to the power of 2 times x to the power of negative a half, right? So y prime would just be, bring that negative a half to the front, so 2 times negative a half, and then x would be negative a half minus 1, okay? So these cancel, but the negative 1 remains, so negative x to the power of negative 3 on 2. And we would probably just leave our answer like this, to be honest. But yeah, something like that. Or we can even combine, right? We can say, well, y equals to root x x. Find the derivative of this. And you might be thinking, whoa, I've never seen a question before that has 2 x terms. How am I meant to differentiate that? Well, all we have to do is combine these x terms. So this is x to the power of half times x to the power of 1. And what do we have? What do we do when we have bases, the same base to the power of something? Well, we add their powers together. So we get x to the power of 3 on 2, right? 1 plus a half. So y prime, we just bring that 3 on 2 to the front. So x, and then we drop it by 1. So 3 on 2 minus 1. That becomes 3 on 2 x to the power of a half. Or that just becomes 3 root x divided by 2. So that would be, a couple of examples of that. So questions might then go one step further and make you use the quotient rule, right? So something like y equals to square root of 9 minus x squared, right? So this is obviously, or hopefully you remember that this is the form of a semicircle, right? Because it's a plus here. If it was plus minus, that would be the whole circle. But yeah, something like this, again, you would have to rewrite it as 9 minus x squared to the power of a half. And hopefully then you see, oh, I can just use the quotient rule here, right? And you'd be absolutely right. You can just use the quotient rule. So we differentiate what's inside the bracket. It'd be minus 2x. And then you times it by kind of the derivative of the whole thing. So this half comes to the front. And then that bracket stays the same, 9 minus x squared. And then that half drops by 1. So it becomes minus a half. So these 2's cancel, or 2 and a half cancel. So it becomes minus x. And I'm going to bring this to the denominator, divided by root, the square root, because it's a half as well, 9 minus x squared. And that's probably the simplest form and how I would leave my answer, right? And just finally, we might have cases where they combine everything we've gone through so far. So what if they gave us something like 6x plus 3 divided by root x, You look at this and you're thinking, wow, what a very complicated question. There's 2 terms of x, there's a square root here, one of them is in the denominator. This must be impossible, right? Well, actually, we're just going to combine everything we've learned. The first thing is these bunny ears I told you about, when we can differentiate like this. Note that this is not the same as if this was, something like root x divided by 6x plus 3. You could not divide like this. That is, those are not bunny ears. You cannot do that. You can only do it when it's like this, right? So we get y equals to 6x divided by root x. Well, let's actually write that as 6x, let's keep it as root x, plus 3 over root x, right? And then now let's bring everything to the numerator. So y equals 6x times x to the power of minus a half. I've changed the square root to a half, and I've brought it up so it becomes a minus, plus 3x to the power of minus half. Let's just simplify that one last time. It becomes 6x to the power of a half plus 3x to the power of minus a half, okay? So finally, now we can differentiate this. There's a plus here, so remember when there's a plus, we can kind of think of these as separate terms. So we bring the half to the front of this one. It becomes 6 times a half, x to the power of minus a half, bring the negative a half to the front, so plus 3 times negative a half, x to the power of negative 3 on 2. Simplify everything, we get 3x to the power of minus a half. This becomes minus 3 on 2, x to the power of minus 3 on 2. So this becomes 3 over root x. I'm just going to leave this as it is. I'm not going to bring it down to the numerator. Oh, actually I can. Let's do minus 3 on 2x to the power on 3 on 2. And so this would be my fully simplified answer for the derivative of something that initially seemed so complicated, but we were able to break it down and then into a form that we can easily recognize and just differentiate it, right? So yeah, these are the, I guess, kind of ways that they can make these questions difficult. So now have a go yourself at these 4 questions. So in part A, we have y equals to x times 4 root x. What we're just going to do is combine those two terms, right? So x times x to the power of a quarter, which is what 4 root x equals. We combine them and we get x to the power of 5 on 4. So we differentiate that, bring the 5 on 4 to the front, and then it's 5 on 4 minus 1, right? So 5 on 4 x to the power of a quarter. And then we can either leave it like that, or we can just say 5 on 4 quarter root x. And that would be part A. Part B, we've got x over 2 root x. So let's bring that root x from the bottom to the top. So we get y equals to, and actually let's separate that half as well. It's getting annoying, right? So we get x times x to the power of minus half. If we combine that, we get half x to the power of a half. So we can differentiate that fairly simply now, right? Y prime equals a half times the half we brought from the power, x to the power of minus a half, right? So that becomes a quarter x to the power of minus a half, or just 1 over 4 root x would be our answer there. Part C, a little bit harder. We can write that as y equals to x plus 5 to the power of negative a half. So y prime equals, well, we'd have to differentiate what's inside the brackets first, don't forget that. But because there's no number in front of this x, well, the derivative of x plus 5 is just 1, right? So 1 times, bring that negative a half to the front, negative a half, x plus 5, and then minus a half, minus 1. So it becomes minus a half, x plus 5 to the power of minus 3 on 2. And you can leave that however you want, but I'm just going to rewrite that as minus 1 on 2 to the power, or x plus 5 to the power on 3 on 2. That's my answer there. And finally, part D. So we got y equals x cubed plus x squared plus 1 divided by root x. And we're going to use those bunny ears, except it's going to have, I guess, 3 bunny ears. But still bunny ears regardless, right? So we're going to write that as y equals to x cubed over root x plus x squared over root x squared over root x plus 1 over root x. And now let's bring the root x's all to the top. So x cubed times x to the power of minus a half plus x squared times x to the power of minus a half, and then just plus x to the power of minus a half. So let's combine all these. Well, what's 3 minus a half? Well, that would be 5 on 2. What's 2 minus a half? Well, that would be 3 on 2. And then x to the power of minus half would stay the same. So now we can differentiate this again. We think of these 3 as separate terms because there's pluses in between them. If they were multiplying, then we would combine them first and then differentiate them, but that's not the case here. So we bring the 5 on 2 to the front, 5 on 2 x, and then it's 5 on 2 minus 1. Bring the 3 on 2 to the front, 3 on 2 minus 1. And then finally, I'm just going to write this as bring minus half to the front, and then x minus a half minus 1. So let's simplify everything. We get 5 on 2, x to the power of 3 on 2, plus 3 on 2, x to the power of a half, minus a half, x to the power of minus 3 on 2. And you can just leave your answer like this, probably is fine as well. Unless your teacher specifically asks or tells you that they really don't like negative indices, well then that's fine. We just have to rewrite this term as minus 1 over 2 x to the power of 3 on 2. And this would be the answer to this question here.